In this video, we'll be evaluating cosine law to solve for an angle. So, I wrote down a triangle. It says solve for angle C. And the triangle I've labeled ABC. This side is capital C, it's the angle C. So this side is baby C. And this side here is, this angle here is angle A, so this side's baby A. And this side here is angle B, so this side's baby B, or lowercase b. We're asked to solve for angle C. You could just solve for angle C. I'm going to put an X here though. It just helps me. If you want to do that too, you can. Normally, you'll be given sine law. You don't have to memorize it, but here it is. You'll be given cosine law. You'll also be given sine law, but in this case, we're doing cosine law. Cosine law is c squared equals a squared plus b squared minus 2ab cosine of c. And I'll just point out here, this formula looks a lot like Pythagorean theorem, c squared equals a squared plus b squared, but it continues on because it's not for right angle triangles. You can use it, but really there's better things. With right angle triangles, you use Pythagorean theorem or SOHCAHTOA. Cosine law we do with not right angle triangles. Looks just like Pythagorean theorem, c squared equals a squared plus b squared minus 2 times a and b, the same letters, cosine of the big letter of this side. Okay, sub in. First line's the formula, second line sub it in. The baby C is 7, baby A is 9, baby B is 14. Take away 2 times those same numbers. Cosine of, I don't know. You can leave it C, but I'm calling it X. Alright, got to do some math here. You can do that in your head. Use a calculator, won't judge you. This is 49. 9 squared is 81. 14 squared, that one you might have to use your calculator. What's 14 squared? 196, but I'm going to check. Just not as confident with that one as I am with others. 196 is right. Take away 2 times 9 times 14. I'm going to use my calculator, just like I said for you. No problem if you use a calculator. 2 times 9 times 14, 252. Alright. Put this cos x in brackets. You don't always have to. It wouldn't be incorrect to leave out the brackets. I just like it because it reminds me this is 252 times cosine, which is where the major mistake many students make is. You'll see. Right now I'm going to do 81 plus 196. What's 81 plus 196? 277. Okay. Here's where so many of my students go wrong. They try to do 277 take away 252. Why can't you subtract this, take away this? Because it has a timesing here. This is 252 times cos. It can't be subtracted. It's not a number take away a number. It's a number take away a number with a cosine on it. You can't do that. You cannot subtract here. So what do you do? The answer is we're going to get rid of this 277 on this side and end it up on this side. But you can't just move it over. Instead, you get rid of it by doing its opposite. It's a positive 277. We're going to subtract 277 both sides. And when you do that, you get, let's see what 49 take away 277 is, negative 228. But here's the beauty. This 277 minus 277 is 0. And you're just left with negative 252 cosine of x. And now, we do what we always do when you have timesing. This is a number times something else. And how do you do the opposite of timesing? Dividing. Divide both sides by negative 252. And let's see what you get. Cos x is going to be whatever you get when you do 228 is negative 228. I could have left the negative out because I know negative divided by negative is positive. But I put it in, divided by, put a bracket just because I like having that brackets to show divide by this whole thing. And I get a big decimal. I need to write them all down. 0.904761 904. Interesting number. 904,761, 904. Now, I took all the decimals, but my calculator would have definitely had to round. I need a rounding dot here. Not done yet. I have cos x, but I want to get x by itself. How do you get x by itself? Well, you can't just divide because this isn't timesing. This is cosine of x. It's not multiplication. It's a function. How do you do the opposite of a function? the function's inverse or opposite function, which is cosine to the power of -1, or inverse cos. We reverse cosine on this. Got to write down that number again. 904, 761, 904. And when I do that, I've got x by itself. This cosine has been inversed on this side. Didn't need a rounding dot there because I didn't round. Look, from here to here, I had to round. This fraction became a rounded decimal, but from here to here, I left it exactly the same. There's no rounding, so this is just a straight up equal sign. But this last one I'm going to round, for sure, because I'm going to round angles to the nearest degree. I'm going to go inverse cos, that's shift cos. See how it says cosine to the power of -1, brackets. You don't really need the brackets on most calculators, I just put it just for safety. 904, 761, 904. And when I inverse cos that, I round to the nearest whole number. I got 25 degrees. So this video has shown you how to solve for an angle using cosine law. We wrote the formula, we subbed in, we did some calculations, did this square, and this multiplication, and then we added these two numbers together and got 277, but we can't subtract here. Very important. We had to take away 277 both sides. We were left with -228 equals -252 cosine of x. How do you get cos x by itself? Divide by -252. Once we were there, we had cosine x equals a big long decimal. We inversed cosine and we solved.